So welcome everybody. I'm very happy that we can present today on modern data warehousing with Datavault Builder on Azure Synapse Analytics, together with our partners from Microsoft. My name is Peter Belles. I will present the second part of the presentation about the Datavault Builder and how it interacts with Synapse Analytics. The first bit will be by Florian. He will introduce himself and explain us what is so great about working with Synapse Analytics.
Is it coming? Okay, great. So hello also from my side, and welcome to this webinar on building a modern data warehouse. I will present the part on Azure Synapse dedicated SQL Pool, which is part of Azure Synapse Analytics. And my name is Florian Follony. I'm a cloud solution architect for data and AI in the Microsoft partner organization for Switzerland. Yeah, and let's have a quick look at the agenda for today. So what can you expect from the seminar today from my side? I will quickly speak about the data warehousing challenges, some challenges I've actually seen firsthand during my time before Microsoft, when I worked as an IT consultant for various companies in the field of data warehousing and business intelligence. Then we will speak about what is Azure Synapse Analytics, and we will discuss one of the components of Synapse Analytics in more detail. This is dedicated SQL Pool, which is basically the component for data warehousing in an enterprise. And finally, I'll also speak a bit about the integration part and specifically how Synapse integrates with Power BI. So let's kick this off. And before I forget, if you have any questions, there should be a Q&A button in Zoom where you can already write your questions during the session, and Peter will do his best to answer them directly. So, but now let's get started. So I hope it doesn't come as a shock to you that building a successful data warehouse can be quite challenging. And as mentioned, I've seen this actually myself in various projects. I used to work for a central data engineering team in an insurance company that had an on-premise data warehouse. And yeah, everyone expected that this would work quite well, and that this data warehouse would really support data-driven decisions throughout the company and enable different lines of businesses, that it would also scale perfectly and would be operationally efficient. It would also create great customer insights and enable the business, and also, yeah, finally be equipped with a robust and frictionless data governance. But the reality looked a bit different. In reality, we were a central engineering team inside the company, which was, often entirely overloaded with requests coming from all sides. The reason for this is that we didn't have the technology really to scale and to work in parallel on different parts of the data model. It was also often difficult really to scale from an infrastructure side. So if someone brought up a new use case, then we first had to order a server because we had to tell the one requesting this use case that we're already at capacity, and this could take months or even longer until the server was installed and ready to be used. So this was a problem, and then also deploying and developing things was quite a hassle because we were on premise, and you know how it is. If you're coming from the site, then the development processes are not as integrated as they often should be. And various other problems you might also have heard before, like lack of data quality, that the data resides in different silos in the company. These are all struggles that we really experienced firsthand. And this was not a single case. And in another project, I used to work for another insurance company, also here near Zurich. And they also had this problem with the data silos. And they at one point, the data scientists, they were so frustrated that they didn't get the data to do their job, that they started to order new hardware on Digitech Galaxus and started to build their own data warehouse in their office and only for the data they needed. But of course, this cannot be a solution in long term, and also I hope this is something that doesn't occur more often. So what it wraps up, building data with a successful data warehouse is quite challenging. And some of the problems I mentioned are probably also, they cannot be solved from a pure technological perspective, but I believe having the right technology in place really matters. And this is how I want to introduce Synapse Analytics, which is our solution for building a data warehouse in the cloud. So what is Synapse Analytics? Answering this question is actually not so easy because it's quite a broad product which has several different components. But in general, it's a unified analytics platform that has a collaborative workspace, and it enables various roles in an organization to work via a single interface and perform various jobs, from building ETL pipelines, doing analytics on the data, managing the data, the security, and also integrating this with machine learning if needed. So here's a broad overview how this looks. Inside of Synapse Analytics, you have these various components. You have, for example, components for the SQL part, which is more really the traditional data warehousing. And then you have also a component that is called Spark Pool. So you have you can directly deploy a Spark cluster in Synapse Analytics and run Spark jobs. And you have several other things like a data explorer. So this is more something that you would use, for example, to do log analytics or stream analytics. And you have all this available in a single platform. I think this is one of the huge advantages. So, for example, you can start with SQL, and later, if you notice you want to do streaming, you can simply deploy a data explorer pool and go in this direction. Or if you want to go in the direction of Spark, or you want to start with Spark, this is also possible, and later move to SQL. So really high flexibility here, and all via a single interface. So Azure Synapse Studio is really like a very powerful component in building a data warehouse, but it's not the only one. And because building a modern data warehouse can be quite a challenge, there are also other products that play around in this area. And this is also what Microsoft calls the data intelligence platform. And Synapse is a key component of this platform, but not the only one. So if you want to look more on the governance perspectives, then you would probably look at Azure PureView, and this integrates quite well with Synapse. And then you have a whole way of providing, for example, insights and what data resides in your data warehouse. You have this data catalog, you have an option to classify the data and all these things, and you can simply plug this in if you need it and integrate it with your existing data warehouse. And what's also interesting, like Synapse supports various levels of code. So you can work low code if you want. You have the whole part that is also present in another product of Microsoft, which is the Data Factory. So that you can create ETL pipelines with low to really no code at all, if you want to do that. But you can also go full code if you like and work with Spark and Python notebooks. So extremely powerful in the way how it supports different roles and different levels of IT skills. Since this is really what makes which makes Azure Synapse so powerful. This is actually how the studio looks. You have a single interface here. You can work on the data. You can create clusters here under Manage. You can monitor jobs. You can build integration pipelines and develop in SQL or Spark notebooks. And you have various other tools that are integrated here on the platform, including also a whole DevOps part. So this seamlessly integrates with Azure DevOps. So you can do branches, you can check things in, you can deploy things via the platform. This is also very nice for everyone working here in the same environment. So maybe you're thinking, what kind of scale is this Synapse for? And Synapse can support various scales of data. If you're talking about gigabytes of data, maybe 10 users, this is possible and makes sense. But it can also go higher if you have hundreds of users and you have to move and store terabytes of data. This is also all possible because the platform scales and has this really serverless PaaS architecture underneath that scales very well and supports different workloads. And it has also a cost-effective way that we describe as pay-per-use, so pay as you go. And it's a pay-per-use model, basically. So the things that you're using, you will pay for, but usually you don't have to commit upfront to a certain amount of hardware. And this also makes the platform more scalable and easier really to work with. So as mentioned before, there are various components that play in this area of this data intelligent platform, and Synapse is one of them. So when you would work with Synapse, you would probably use it to store or process the data, or both. And this is how this could look like. You have Synapse pipelines at the beginning to load the data into a Azure Data Lake storage. Then you have various components on top of that, for example, Spark pools that you can use to analyze the data and bring the data into Power BI. You have serverless options and dedicated SQL pool. And I'll speak a little bit more about that in a minute when we go more into the components. And this integrates really well then also with the underlying storage options. So, so now coming to the main part of the presentation, which is dedicated SQL pool. And this is really the component which you would use to build an enterprise-grade data warehouse. You have a second option here, which is serverless, and sometimes a bit confusing, like what are these two options? So I try to explain a bit the difference. So serverless is also a PaaS model, but it's different from dedicated SQL pool in that you have a scalable architecture that you deploy, and it's always available. You don't have to commit anything upfront. It's ideal for ad hoc queries, or when you just need some compute power on demand and has to be instantly available, and you don't have to use it like on a regular basis. Dedicated SQL pool, in contrast to that, is something that is even more powerful, and it's also a bit more consistent in terms that you have really some resources really reserved for you. So you also have to say how much resources you need, and then these resources will be provisioned for you, and they are always there, unless you stop the whole thing. And yeah, there's a more complex architecture underneath, which is very scalable and also distributes the jobs, the SQL queries, to several servers, and it can really achieve state-of-the-art performance. So dedicated SQL pools really for mission-critical workloads when you really want to place, maybe you already have a SQL data warehouse on-site, on-premise, then dedicated SQL pool would be the product that could really replace this in the cloud. Oh yeah, and it was formerly called actually SQL Data Warehouse. So as the name says, this is really for data warehousing. What to say? Yeah, here we have, I would like to speak a bit more about what happens under the hood for dedicated SQL pool. So we have this massively parallel processing engine in dedicated SQL pool, which distributes the whole work among several compute nodes. And this works as follows. We have one control node that communicates with the application or the user that enters a SQL query. And then we have several compute nodes in the next level. And the control node distributes the work to the compute nodes and also makes sure that the data is there to complete the job. So one level below, we have the whole storage. And it's important to note that storage and compute, these are two different things in dedicated SQL pool. So this is really entirely decoupled. And this has the advantage that you can pause the whole pool, but the data is still there. So for example, if you don't need the whole cluster to be up over the weekend because no one's using it, you can just pause it. But when you turn it on Monday again, the data will still be there. Yeah, so this is a massively parallel processing architecture which distributes the workload across several nodes. And if you're coming from a traditional on-premise SQL Server world, then this might be a bit different. And I explain also a bit what are the differences compared to a normal SQL Server database. So yeah, but I come back to that in a minute. Just to speak a bit more about how this really scales and what you have to do when you want to provision such a dedicated SQL pool. So if you create this resource, you have to say like how much compute power you need. And the compute power is measured in data warehouse units. Data warehouse units, this is basically a measure for the number of compute nodes that you need. And you have the choice between level 100 to 6,000. Here, it is interesting also to mention that below level 500, you will have a single compute node. And so if you execute a TS SQL query, this query will be performed by one node, but it will be more powerful if you go up to 500. Above that, you will have several nodes that really distribute the work. And if you go to level 6,000, you will have up to 60 different compute nodes that can execute a T-SQL query in parallel. And this is actually what really leads to the state-of-the-art performance. And each of these nodes will be connected to a separate distribution of the data that resides in the storage underneath. And there's a bit also difference when you're coming from the traditional SQL Server worlds, and this might also be a bit a change of yeah, you really have to adapt to this and understand how this works. Because if you create a table inside this dedicated SQL pool, it will be split into several parts that are residing in basically up to 60 different smaller SQL's DB storages. So there are also different ways how you can distribute the data. You can equally distribute the data so that each SQL DB will hold a specific, will hold the same partition. This is quite useful, for example, if you want to create a table for a dimensional table that, for example, contains some address codes, or so that you need to complete a job, but it's very useful here if you have it on each node and each distribution present, because then, yeah, you don't have to move the data around. And if you're coming from Spark world, then you will know that it should always be the goal to have as little data movements between different nodes in a cluster as possible, because then the queries will perform faster. So as mentioned, the cool thing is also here, you can really pause the compute node if you don't need it, and then you can reduce the cost to a minimum, and it will not pay for the compute nodes in between. And then you can easily also resume the node. And because of the scalable architecture, you can also quickly adjust the sizing of the whole cluster. And for example, switch to a higher or lower size. The only thing that you have to keep in mind here is that this requires restarting the server. Our recommendation here is really to start with a small cluster and take some typical jobs and see if they perform well. And if not, then you can move to a higher cluster, and then, yeah, try to find the one that best fits your needs. There are also various performance optimized technologies here that you can use that are built in. For example, the whole thing uses a columnar storage, which is very performant. And you have also materialized views, hash distribution. Not gonna go too much into detail here, I think, because of time. But these are all technologies that are built in, and some are also, you might know already if you've been working with SQL Server databases before. So I think some of these differences between SQL Server and dedicated SQL Pool I've already mentioned. Quickly go through that. Yeah, what really separates SQL Server from a dedicated SQL Pool is really it all comes down to the architecture, and then all to the fact that dedicated SQL Pool runs in the cloud, and SQL Server is usually something that you deploy on a VM or on your premise hardware. In terms of scalability, when you want to scale a SQL Server, you will typically do this via the hardware. So you will try to build in more memory, more gigabyte of disk memory, or a stronger processor. And in the cloud with the dedicated SQL pool, you can add additional nodes to your cluster, and this scales better and yeah, basically endlessly. In terms of architecture, for SQL Server, you typically have a single server, and for dedicated SQL pool, you have several compute nodes. And when it comes to the integration with Azure, this is also a big advantage for dedicated SQL pool in the cloud. As mentioned, it integrates well with various other Azure products, like, for example, PureView or Power BI or Machine Learning Studio. And integration with SQL Server is also possible, but it's just not as seamless. Yeah, we already talked a bit about the cost. I mean, when you create a SQL Server, you have to pay upfront, and in the cloud, you're more flexible and pay what you need. So finally, quick look at how this integrates with Power BI. Power BI, I'm not sure if I have to explain this, but I will say a bit about that. This is basically the business intelligence / reporting solution from Microsoft. It's part of the Microsoft Power Platform, which is also a bundle of different components that are available out of the box in the cloud. And it integrates seamlessly with Azure Synapse. So if you want to do reporting, then Power BI is a great product, I think, which can work quite well together with the dedicated SQL pool. There are different options for integrating this. You can do a traditional import. This will basically just create a copy from the data that already is in the data warehouse in the workspace in Power BI. But I think the best option is really to use direct query here. You can query the data from Power BI directly in the dedicated SQL pool without any data movements. And then you can do reporting and dashboards directly on the data without having to move it around. And there's a third option. You can also integrate Power BI directly in the Synapse Studio. Then you have various functions to create reports, to view reports, and to share them directly in Synapse in the workspace, which is also quite cool, I find. So key takeaways. Yeah, if you're planning to build a data warehouse with an enterprise-grade performance and security level, then a dedicated SQL pool is really the way to go. And also keep in mind that Synapse Analytics has these different components, so you can start with a dedicated SQL pool. And if you later decide to go more in the direction of Azure, of Spark, then you can do that as well. And you just have to create a Spark pool, which also can use the data from the dedicated SQL pool. And if you want to do ad hoc reporting, or you don't need like this consistent level of performance, then maybe serverless might be a better option. So yeah, finally to say, think of Synapse really as the heart of the whole data intelligent platform, which plays well with various services around it, including Power BI, PureView, and machine learning. So usually when you will get started with dedicated SQL pool, you will also have try to get an overview of the other products in the Azure world and how they integrate with each other. Yeah, that's it. Thank you so much. And if you want to get started with dedicated SQL pool, I've included a couple of links that you can use and where you can easily get more information.
Thank you a lot. Good. So far, no questions. So I would continue and take over, and thank you for presentation of Synapse. And I will show you now how we take this up and how we use Azure Synapse to bring some data warehousing functions to you. So what is the main problem we are solving? Today, usually it is not the issue that companies don't have enough data. Usually they have many different IT systems and the data is spread all over the place and we need to bring it together. And for this, we need a platform where we can store and integrate the data. And this is why we have created the Datavault Builder in combination with analytical databases like Azure Synapse Analytics. How does this work? The idea behind the Datavault Builder is that we start with the business model. The business model is about what your company is really doing. What are your business processes? Which things, places, people are involved in your daily business process? We model them in the Datavault Builder. We have these blue boxes. Here I have a sample model of a ground handler that is working at the airport, delivering baggages and meals to airplanes. And they might say, we are servicing flights, so we add the concept of a flight to the canvas. We add the airplane, the caterer, and the destination airport. And this is really different from working directly at the database level with some tables or anything. We're working here at a much higher level. We're talking to business people, and we collect all the knowledge they have about the business processes. Because the cool thing is business processes are usually stable, at least more stable than technical processes, because there you might have changes in source systems, external data deliveries, some modifications in between versions of source systems. And here the business stays stable. And in case the business doesn't stay stable, the IT below it will change anyways. So then you haven't lost anything. So this is the main starting point. Involve everybody, talk with a very simplified visual representation of what you're doing, and agree at least on a bit of the data model. Don't worry, we are not doing here what we have done when I started in data warehousing, where we created for months enterprise data model. This is here about doing a workshop, maybe 2 or 3 hours, and defining what is the first part that you want to resolve, where you want to create your reporting based on this. Here, these blue boxes are the concepts. Then in the second step, we add the relations. And if we translate this into the data vault modeling paradigm, the blue boxes will become hubs, the relations will become link tables, and we have here already the small dots. They will hold the context or the attributes describing a concept. They will become satellites. And we have these big colorful bubbles. We called them back then subject areas. Today, in the realm of data mesh, some people refer to this as data domains. There are different names for it. It's a logical grouping of elements into the same topics. So what is then different if we say data modeling existed now for about 40 years? The difference is that when you model something in the Datavault Builder, it's reduced to a minimum that even people the first time working in your workshop understand what it is about, and it's translated in real time into working code. This means we will create tables in your Synapse Analytics database. We will create views. We will create load statements to move data in your database while you're modeling. And this means that when you do here something, you can see immediately what the effect is. You will get the results back. And because the database is so powerful, without nearly any delay. But this is not everything. This is an important part of the Datavault Builder application, but we're covering everything around it. We support you in infrastructure automation. I will show you, you can run this whole thing on premises, but as well on Azure. We are as well facilitating regression testing. So we have APIs that you can completely using Azure DevOps to automate your CI/CD pipeline, automate regression testing, and be sure, even if you do very often new deployments to your production system, that everything runs well. Operation is built in, so we have a built-in scheduler, but you can use external schedulers to trigger jobs in the Datavault Builder and integrate with other Azure tools like Data Factory to preload data, then trigger some jobs in the Datavault Builder. That works fine. We generate in the background as well documentation, data lineage, and we have a built-in data profiler. So let's have a look what the different functions are. It starts with the infrastructure automation. The software is delivered in a way that it doesn't need to be installed. It just needs to be started. It's in a format of a Docker container, of several Docker containers, in fact. And you can start them directly on an Azure VM. You can run them with a Kubernetes service on Azure. But if it's necessary, you can run the Docker containers as well on premises. And this gives you the freedom really to choose at which point in time where you want to run. The tool is completely stateless, so you can start on premises if you don't have the legal work done yet to move to the cloud. stop it one day when you're ready, start it on Azure, and as well, you can move it between different Azure regions, whatever. And like Synapse, you can stop it at any point in time and restart it later. So if you just need to reload your data during nightly reloads, that's fine. Start it up at midnight, stop it when it completed loading, and then all data will be residing on your Synapse database. What we do as well is the conversion of data models into code. So we're creating the tables, we're creating the indexes, and this here is optimized. This means that if we are creating this for SQL Server, it will look a little bit different than for Synapse. If we store metadata, it will look a little bit different between the two versions. If we load data, it will look a little bit different because we're optimizing it always for the target database platform. Difference to other tools is that over time, and we think always about a lifetime of 10 to 15 years of such a data warehouse solution, is what will happen to your physical implementation over time, because maybe Synapse has new features, you want to use them, and it would be really sad if the database offers something that your implementation doesn't. So we are sending you updates for the physical implementation that we're generating. We're sending you updates for the pattern, translating data models into code. And what happens if somebody changes your code in the database? What happens if somebody goes in there and deletes a table? We are monitoring that, and if this happens and somebody does technical changes, we will update the data model as well. As mentioned before, we are automating as well testing, so you can set up a completely new environment, load the data model, run your tests, and get the results all through REST API. So in case your testing tool, and most of them do, supports REST API calls, you can completely automate testing with your existing testing infrastructure. Deployment is built in because if you work Agile, you don't have only one production system. You will have at least your development machine, your test machine, and production servers, and you need to transport your changes between the different systems. Maybe you want to as well use a distributed development process where you have sandboxes for every new feature you're developing, to use Git flow later on in the deployment. And this is all supported with the Datavault Builder. So the Datavault Builder can compare two different environments, shows you the differences. You can select what do you want to deploy between the environments, and then roll out the changes automatically. Or if you use the distributed approach, it will generate you files to check into your Git server. So you can use GitHub or similar tools to version your code and to create as well branches of your data models and merge them later on together. If you're tired of doing this manually, you can use tools like Azure DevOps as well to control the full CI/CD pipeline. We have REST APIs for downloading models, uploading models, comparing models, and deploying models. Operation is built in, so based on the data model, we'll calculate what needs to be loaded in which order. We are monitoring as well what the success was of these loads, how many rows were processed, and you can use the built-in scheduler, but you don't need to. You can as well use your external scheduler if you have already one, and use the REST APIs. And if you want to achieve high availability, we can help you with that already with Synapse. We have a good starting point that the database is there and maintained, and we can show you as well how to manage to do the same with the Datavault Builder. What I don't have on my chart here is that we generate in real time as well the data lineage information. We create a documentation for you, and there is data profiling tool built into the Datavault Builder. If you want to see how we compare with other tools like from SAP or Oracle, just feel free to go to our webpage and download the Barker report. They ask users of such tools how happy they are, and our customers were the happiest and had the highest recommendation rate, valued our support quality, and what I'm very proud of is the time to market aspect, because this is really why we have created the Datavault Builder for. So how long does it take if you have a new requirement until you can deliver in a production-ready version the data to your data consumers, but still in a way that you can maintain this over time and expand it over time to extend your data models. So what do we cover? The first thing is we have a model-driven approach where we would design within the tool the data model, and in real time, we're converting this into working code, database tables, database views, and load statements. And even if this is mainly about Synapse today as well, we support SQL Server in all its variants. And I will show later that it can be a path for you, maybe if you're still on premises, to start with SQL Server and move then later on to cloud-based solutions, move to Synapse if you grow. And this can be a very nice story over time without needing to refactor your solution. The next thing that we do is after we modeled everything, we want to stage the data. And here we have two different options. One is there are built-in connectors to connect directly through JDBC to data sources. We can read Excel and Access files. We can connect through gRPC to Python scripts to load data. We can connect through Trino to stuff like Kafka, Parquet, or Iceberg files. But as well, you can use the built-in Synapse connectors, which are already optimized to use the different nodes of Synapse to stage the data. So it's perfectly fine if you use the built-in Microsoft tools to bring the data to the database. We can work with that. And if you do that, then we pick it up using ELT and don't use the built-in connectors and can drag the data through the process, because everything from the staging layer downstream is ELT anyways in the Datavault Builder. So when you stage your data, you created your history and you have your unique source of facts on top, you can create whatever interface you need. Because yes, the Datavault Builder always creates a core in the Datavault format. We know this helps us with storing the data, maintaining the data, refactor the model, but it's not how people consume the data. So don't be worried if you are using tools that want to use a dimension model like Power BI, that's fine. We can define this at the interface layer. If you want to output third normal form data because you want to consume it by other applications, that's fine as well. If you want to use for machine learning or AI models completely flat tables with all the features denormalized, that's possible as well. And if you have bigger installations, you're running several instances of the Datavault Builder in different Synapse databases for the different data domains, you can create data products. No problem. Here you really define based on the consumer's need what you want to do. As this is all ELT, the data at the end is presented at the Synapse level to Power BI, so you can profit here really from the good connection, from all the offerings that you sometimes don't pay any traffic between the database and the reporting tool if you everything used from Microsoft. So that's very cool. It's very fast. It's in the same compute centers. So that's a very nice integration if you want to stay within one ecosystem. So where does the Datavault Builder run? And here it depends. We have clients running the Datavault Builder on-prem, maybe with a local SQL server. They have maybe anyways already running. Then they maybe set up a more powerful machine and they start growing. Later on, they decide on that the management on Azure is very cool, that you profit from having infrastructure as a service. So they maybe switch over to a SQL Server managed instance on Azure, which is very, very similar, a little bit different than the SQL Server in managing permissions. And they don't need to worry because they can move their data model and the data from on-prem to the cloud. The Datavault Builder itself is completely stateless. This means that you just stop it on-prem, you restart it on Azure, and it connects again to your database. And as long as the same data is present there, it will pick up working where it left off before. And here again, already you can switch when you need more power to Synapse Analytics database. And here you have a lot of flexibility. We heard it before. You can scale it up, you can scale it down, you can turn it off overnight. And Datavault Builder supports all kind of this functionality. As long as we can connect to database having all our metadata, that's fine. And the next step that we're right now already doing with the first clients is that you can get as well a managed instance of the Datavault Builder where the solution will be deployed into your Azure tenant in a separate resource group. Within there, it will be supported by a central team, and It will upgrade it based on your requests by a central team, but still, we don't see your data. It's disconnected from the outside world. It's running with your tenant within your resource group. There's one, okay, there's two questions. I will answer them a little bit later. The cool thing is that you can move between any solutions at any point in time without any cost from the Datavault Builder perspective, because we are not storing any data. All the data is in the database. And what do we do different than other providers? A classic automation approach is that you have a modeling tool, which can be something classical like Irvine, like Power Designer, and you work usually against the repository. So you work against database, against flat files, you define all your metadata. At some point you press the button, and from the metadata, the implementation will be generated on the database. And this works in the beginning. The issue with this approach is that it can be that somebody changes the implementation at the database level, and if you don't resync the data model, at some point you will realize that the data model doesn't match your implementation. People start distrusting the model. Less and less people use the model. More and more people start doing changes directly here, and everything falls apart. And this didn't happen only to us. We did a big research, and we figured out that this happened to many other consultancy companies as well, that in the beginning everything worked fine with this approach, but over the time it fell apart. So what we did, we changed it. And now if you work in the Datavault Builder, there's no repository. If you do something in the data model, immediately you see it reflected in your Synapse database. And if you change something there, it's reflected as well in the model. Don't worry, we are not doing this on your production system. You're working here on your integrated development environment if you're a smaller team, or even in your own sandbox database. And then we have a ITIL compliant way of deploy the changes from development to test to production with code versioning and everything. So example, I add here a concept in the data model. In the same second, the database table is added here. The metadata is stored in a separate table on Synapse. On SQL Server, it's even added as extended attribute on top of the object. The whole thing is built for agile development, and our test is usually, am I able, if I have different features here represented as cars, if I start developing something later than my colleague, can I deploy it before him? And that's possible because we make use of the Git flow based process. So you can take your data model from integrated dev environment, you can branch it, you can work in your sandbox, change it, you can commit and push it to your GitHub account. And you can even automate based on that using Azure DevOps different steps, because for every step that you can do manually in the Datavault Builder, there is always a REST API as well to trigger it as well for model downloads, model uploads, model comparisons, and model deployments. So what is the other point that we do different than other tools is that we believe that the physical implementation of a data warehouse changes over time. Even the data don't. Why? One good example is you start maybe on SQL Server, later on you want to go to Azure SQL, and later on you want to move to Azure Synapse Analytics. If you do all of this manually, you need to maybe change your structures, maybe you need to change the index types here, and you need to migrate your data. With the Datavault Builders, we have the data model, and based on that, we can generate different implementations again and again. And we don't deliver you just the new patterns for the new database, but we deliver you as well the update script. So we have some clients that started back in 2012 using the Datavault Builder with SQL Server, and they're still able to upgrade to the newest SQL Server version that has completely new functionality, new index types, profits from different SQL query types, and they never needed to update manually their physical data model. So let's jump for a second in the live demonstration that you see how the tool looks like. And I will give you just a short demonstration. Because I don't show something here in the live demonstration doesn't mean it's not included. So if you want to come for a full presentation of the tool later, sign up on our webpage for a live demonstration where you can ask as well your question. So this is how the Datavault Builder front end looks like. It's browser-based, it works in Edge, it works in Chrome. And we see here already preloaded from my Git repository data model about the airline industry. We started modeling this in a group session with a client. They told us they're servicing flights, so we added the concept of a flight. There are different elements qualifying the flight, so we added them. And this gave our conceptual data model. And we can add here as well descriptions, so add here already metadata. And when we had the concepts, we grouped them into subject areas, these big colorful bubbles. And as next step, we added relations. So we already understand how stuff is related. And this is really at a level that business users, usually guided by some data modelers, can understand what the whole topic is about. And this here is not the full data model. We can browse here through the data model, see where we end up if we go into different directions. So we can maybe look that airlines have airplanes and they are maybe grouped in airline alliances. We can bookmark this kind of stuff. And this is the first step. In a workshop, understand maybe 10 to 15 different objects, how they're related, and talk with the business what is most pressing issues for them, so we can start prioritizing the implementation of this kind of points. So next level is we need to stage the data. And here we have already a group of built-in connectors. As mentioned, you can use them, but if you're working with Synapse, you can use as well the built-in Synapse staging means, and then use the so-called intra or cross database staging, and then we will just pick up the already pre-staged data and pull it into our process. So here I have already a defined source system. It's a CSV file source system. I select the file, I can select the columns, I can change the column names, I can change the data types, I could change even the queries, but I will skip a lot of things like delta loading or CDC loading. If you have any CDC streams coming in with a lot of changes in one batch, that's possible as well. If maybe you have a SQL server, a source system that is already generating a CDC stream for you. And here we see the benefit of immediate implementation. So it's not just modeling thing, it's implemented at the same time. So the target table will be created, the definition of the ETL flow in that case is defined, and the job is started. This means that a few seconds later, the data is already loaded into your Synapse database. So let's go in here and we can do a short data profiling. We can maybe look what happens with the delays, and it will analyze how the data looks like. And this is really performed on the database. So we have here an interface that helps you do all your queries to analyze your data, but you're sending these queries down to Synapse and ask them, please group the stuff by all these parameters. And that's why it's in that case so fast, because the database gives all these groupings based on the columnar indexes that are very fast to query analytical data. So the next step is, after we understand the data, is that we need to map the stage data to the data model. And this is done by loading, creating a load. And here the tool supports you finding the identifiers of your data in the real world. So maybe a flight is usually identified by a flight number, maybe by a flight date. And this could be answered that your business user gives you. And if you would model in a tool that is not connected directly to your database, you would believe that in the first version, you would generate the code later and find out this is wrong. Here, because we're working directly with the database, we can query the database and it gives us an answer that this is not unique. And it doesn't just tell us it's not unique. It gives us a sample data set, tells us how many duplicates we have. We can look into this sample data set and we figure out maybe that we have some issues with the carrier code because we have code sharing. And the good thing is that we don't call just back the business user and tell them, oh, it's not unique. We give them examples, and based on that, they usually can answer us what the issue is. There's a second issue. So we have a lot of short round trips in the tool, and we see that the origin column is different. So we maybe need to as well include the airport where the flight is departing from. And now, if we found the business key, the tool can generate all the remaining stuff. So It's really a guided flow helping you do the right test and only progress if you're successful. This is for me the classical Agile approach. We still do the same work, but we do it always with testing. And now everything is production ready. This means the Datavault Builder will connect to the ETL process, staging the data. It will expand it to pre-calculate technical keys. It will pre-calculate the composition of the business key. It will start loading. It will load the attributes into the so-called satellite tables. It will create history of it. It will create automatic indexing for the as of now segment of your data. So all of this thing that you need to do over time in data warehousing, it's already created in a few seconds that were followed by the definition of the stuff. So already I can go in here, check the results, and then see how it looks like, that the hash keys were generated we need in Data Vault modeling for joining tables together. The business key is there. And here we see a little bit of standardization that we're using. We have 4 columns given by the Data Vault standard. We have here _h and _bk given by the naming standard that we already deliver with the tool, but you're completely free to call it flight, flight lag, or in whatever language you want to model. So these are the first steps: creating a model, staging the data, connecting it with the source. But to create a tangible output, we need to create an interface, and that would be like the last thing that we need to do. We just define what is the grain, what is the time perspective, is it as of now, as of then, create the interface and drag in the random columns. And the nice thing is here we're sending just create view statements to the Synapse database, and it doesn't need any reloading. We can right away, in case you see it's a live demonstration still. So I haven't loaded the data at all. But if the data is loaded, for querying it, we don't need to reload anything. It's just taking the data that is stored in your raw vault and presenting it to your business users. And in short, this is the basic process of adding one element to your data warehouse. But for adding a second, a third, it will be always the same, and it will be always the same speed. So even in 3 years down the road, you will not be stuck, because all the steps that I showed you will still apply. So adding a new data source in 3 or in 5 or in 10 years will take no longer than what we have seen here, and to add it to the output. Good, so I would now answer a little bit the questions, what we have. What is the name of the Data Vault tool used for data lineage, or are you using PureView? You have here the options, because within the tool, there's the data lineage section that we already do based on the data model and based on the business rules that you have defined. And all of this metadata is available here in the tool. It is available as views on the database, and it's available to you as REST APIs. If you want to use PureView, as Synapse integrates with PureView and we create everything in the Synapse database, you can use it as well. You would use that most probably if you wanted to as well integrate the data lineage with even more tools and extend it to have like an end-to-end lineage, including Power BI and other tools. There's a second question for the data vault diagram. Should the data rules not be applied of the data before it goes into the dimensional models? In our system, it doesn't. Why? This here can be all model driven. This here can be all model driven. And the cool thing is, if I apply the normalization before I go in the business rules, writing the business rules is so much simpler, because I don't need to care if my data comes from a satellite connected directly to the hub, if it comes from something I link to it through 5 or 10 links, but I get everything down to the level where I have everything in one row that I need to calculate my business rule. So this can be done model driven, and the rules then can be very simple, because it's really, you have this kind of view of all the normalized elements and then apply the business rules. So let's switch back over to the presentation. And I would open this round for questions to Florian or me. We're happy to answer them.
Yep, thanks, Peter. Also from my side, it was very interesting.
So one question is, when do I use SQL Server and when do I use Synapse dedicated pools? What is the limit? Where is the border? Or what are the different application cases?
Yeah, I'm trying to answer this one. Well, yeah, if you start with like if you have more ad hoc like use cases where you just query the data, you want to get started very fast and easy without having to load the data into a data warehouse first, then you should get started with SQL Serverless, because yeah, it doesn't really require you to load the data anywhere to get started, and you have it like available at the at the click of a button. And for dedicated SQL pool, getting started is also easy, but it requires a bit more effort. Here you really have to load the data first into the data warehouse, into the dedicated SQL pool. And yeah, this requires some initial effort, but once you get started, you have this really additional amount of compute power that you need for data warehousing, for really complex queries, for longer running jobs. And yeah, like give you a comparison, if you have ETL jobs that take minutes to run, they can take seconds in dedicated SQL pool, or if they take hours, this will be minutes in dedicated SQL pool due to this massively parallel way how things are computed. So I hope I could answer the question a bit.
I would say as well, usually what I say to the people is if you use already SQL Server and you have really low data volumes where you say, okay, it really takes no time to compute it on my existing server, most probably it will be sufficient. SQL Server is a good database, but it was not built for analytical workloads. As soon as you go into queries that take longer and you need to wait and you lose time, Synapse is the better choice. And especially if you need scaling, if you have like end of month work or end of year work where you need to scale up very fast and then maybe scale down again, I think that's a very good use case for Synapse. I don't know if you would agree.
Yeah, I think so. I mean, what you mentioned is true. If you're using SQL Server, you're limited by the hardware of the server, and you can just upgrade the hardware basically. But in dedicated SQL pool, you can just switch to a higher number of compute nodes and distribute the work among several nodes. And you're much more scalable, gives you more flexibility. Yeah, that's it.
Good. Then there is a question, when will be the Azure fully managed Datavault Builder instance will be available? That is already available. It's offered by one of our implementation partners, Matrix in Munich, where you really can say they guarantee you that if you order from them within 1 week, they will set up all the environment. It sounds like a long time, but it's mostly about getting all the firewall settings right because they really deployed into your Azure tenant. The technical work is very fast, it's automated, and they then take care for a charge of all the updates and everything and keep the system running. Then the question is, another question is, how does it integrate with Azure DevOps? And is this already available? The point is the Datavault Builder offers the REST APIs that can be called already today in Azure DevOps pipelines. So this is working. Still with version 7, we are working for even tighter integration. So we will allow as well to do backend check-ins into GitHub and stuff like that. So it will even be simpler that you don't need to even manage the files by the Azure DevOps pipeline. So it gets better and better, but it's already now covering the full CI/CD lifecycle. And there is an interesting question is, how does it look like? How does the migration process from SQL Server to Synapse works? And for the Datavault Builder, it's pretty simple. We say if the data is migrated over and the structures are migrated over, usually we will connect and we will accept the new data model. The point is there are some slight differences. There is not all of the SQL in the business rules that you used on SQL Server is supported on Synapse. Minor things sometimes, but yes, there are small differences. And maybe you can tell Florian how you will recommend to move the data between SQL Server and Synapse.
So there are various things to consider. So first of all, it really makes sense like to do a solid planning, like to really understand what you have to change. And there is a tool that can aid this process. Actually, it's a SQL migration tool that can do the assessment for you and can give you some advice, can provide you also with the link for that. And we also have some SQL migration guidelines with more information on that, and like what to take care, what you mentioned, Peter, exactly. We have some differences in terms of the features that you don't have available directly in dedicated SQL Pool. And also, I think one of the main differences that because in dedicated SQL Pool, you have this distributed architecture, you have to think about how you distribute the data across the different nodes once you create a table. So you should really understand I think there are 3 different types of how you can distribute the data. You really should understand them. I've mentioned one before, that you can equally distribute the data across all nodes. But there are other ways. You can also do like distribution by the hash, so that, for example, you have for each year in the data set, you have each year all the data in one node, which also can really improve performance. And there's another one that will just replicate the data to all of the instances and distribute it equally. So this is really important to understand these differences, and then really to get started with the actual data transfer, you also have several options. You have connectors with Polybase, where you can just query the data from the sources, and you can also use from a SQL Server. You have this SSIS integration package, which is basically some kind of software you install on the SQL Server, and then you have the option to directly query the data from the cloud and move it out of this SQL Server into Azure dedicated SQL Pool, or to a blob storage in between. So this depends a bit how you want to do this, and if you want to do transformations in between in the migration, or if you just want to copy the data one-to-one. That's the rough overview, and I can provide you with the links to more information as well in the chat.
Good. Thank you. I think we could add a slide maybe with such resources to the PowerPoint that we send out.
Yeah, that's a good idea. Let's do that, yeah.
So I would say we have a last question here. How is statistics management work in Synapse in relation to the code that you generate? How do you tune processes?
So basically in statistics, I know it's an important topic, it's a good question. It's definitely also beneficial for performance if you compute the statistics. I just know there is a way like to automatically update the statistics every time you change something in the data. If I understand this right, in relation to the codes that you generate, how do you tune
probably to our code? Is what we do is that we have certain patterns that we optimize for Synapse, the distribution that we heard of, but we usually keep the statistics updates for maintenance script directly at the database level, because we don't know at which point in time it's most beneficial for you, because it could be that you're loading during the day smaller batches of data and the statistics are still fine for last night, but it would block or slow down your queries that you're using with your Power BI direct queries. So usually we keep that out, the statistics management of our loads, but you can schedule them using the built-in scheduler. We have a SQL part where you can say, okay, now maybe 2 o'clock in the night, that's a good point to do that and trigger that.
Yeah, there are also different options available in Synapse to do this, like the automated one, but you can also put it on manual and, for example, schedule at night times. There are different ways, and will depend a bit on like how much workload you have, when the workload happens during the day. So I think what you said, Peter, is absolutely right, that you will try to move these updates out of your busy times, and there are ways to do that.
The good thing is that with the Datavault approach, you never have empty tables. You're just adding always incrementally to the different tables. So you don't have these issues like before, maybe that by chance you manage to do statistics of an empty table and then everything crashes down because all the plans are completely off. No, here it incrementally grows. So even if the statistics are maybe not just 5 minutes old, but maybe 1 day old, it's not the issue because usually still the basic principles apply.
Cool.
I thank you a lot. I thank a lot for your interest, for all the questions that we had. And Florian, thank you a lot.
Thank you too for the invitation. Thank you also for the questions that came from the audience. We are super happy to see so many people interested in like the combination of our solutions. And yeah, if you have any questions also that relate to Synapse, you can also ask me on LinkedIn. Feel free to add me there. I will be happy to link you to some of our colleagues from the account teams. Even so, I work more with the partners. I'm well connected here to my colleagues who can certainly help you.
Exactly. We will send you out as well the presentation with the links, what you can do as next thing. And I thank you a lot and see you soon. Bye. Thank you.